We're going to begin our discussion with hydrostatic pressure and hydrostatic force by thinking about what they are and what their units are. Pressure is force per unit area. And in the system that we use in the US, you might see that as PSI, which is pounds per square inch. This is what you might see on a car tire. And in this section, our area is going to be actually in square feet. I just wanted to relate PSI, something you may have seen in the past. In the metric system, our unit of pressure is the Pascal. And a Pascal is a Newton per square meter. And you may recall that a Newton is a kilogram times gravity. That is, force is mass times acceleration. And so when you're given something in newtons, we will have to remember that for gravity, we need to include a factor of 9.8. It's meters per second squared. We aren't really going to be concerned so much with those units, although they're always there. But the takeaway here is if I have something in newtons, I need to remember to multiply the result by 9.8. A Pascal is a relatively small unit of measure, and so oftentimes we will see 1,000 pascals, which is 1 kilopascal. Now, since pressure is force divided by area, it follows that force in this section is going to be pressure times area. And the units that we're going to see for for force are in the US system pounds, and in the metric system newtons. Another thing that would be useful to know would be the density of water. It shows up quite a bit. For water, density is given by rho times gravity, and that P-looking thing is the Greek letter rho, and in the US system is 62.5 pounds per cubic foot. That's referred to as the weight density, and again, that's in the US system. In the metric system, rho is equal to 1,000 kilograms per cubic meter. Now, this is actually a mass density. And so rho times gravity, the weight density, is going to be 9,800 newtons per cubic meter, bringing in that 9.8 from the gravitational acceleration constant.